Alright, so we have question number 10, last question of the paper of IAL January 2025. It's IAL Jan 2025, and it's question number 10. Quite quite difficult one over here. Show that the cos theta times by 3 tan theta plus 2 tan theta bracket is equal to sine theta plus 2 sine theta. So you have to manipulate this LHS into RHS. Alright, so you have to make sure that LHS is equal to RHS, and we have to prove it. Alright, and so basically over here you have to do a bit of algebraic manipulation, and you should know some trigonometric identities. All right, I will be writing them down, which identity you use and what to do each step by step. All right, now first thing is first. So cos theta, now replace this tan theta by so let me write a trigonometric identity aside. So tan theta is equal to cos theta, no sorry, tan theta is going to be sine theta or cos theta, right? So we replace this 3 tan theta with 3 sine theta over cos theta. All right, plus replace this 2 over tan theta, again replace it with sine theta over cos theta. Okay, all right, now let's just manipulate this identity over here. Let's just manipulate this one over here, right here. So this is basically just saying that 2 divided by sine theta, all right, or cos theta. Now here you have to do is keep, flip and change. So when you multiply it, it's going to go other way around, 2 cos theta over sine theta, and that is going to equal to 2 cos theta over sine theta, right? And replace this thing over here, right? So now we have cos theta, right? And yeah, so cos theta, and we have 3 sine theta or cos theta, right, plus 2 cos theta divided by sine theta. Now the third step is to do is expand the bracket. So you have 3 sine theta cos theta or cos theta, right, plus 2 cos square theta over sine theta. Now over here you should notice that they have eliminated all cos. They have eliminated all cos thetas. All right, all cos thetas are eliminated. So how we eliminate cos theta? So this just cancels out. We have 3 sine theta plus, now you should know that this can be, we can switch to 1 minus sine squared theta, right? Because cos squared theta plus sine squared theta is equal to 1, right? So that's why. Now if we replace this with 2 times by 1 minus sine square theta over sine theta. Now if you try to expand the bracket, you have 2 minus 2 sine square theta over sine theta. All right. All right. Here things gets a bit trickier, and many people wouldn't know what to do over here. So basically now so we have to do bit of algebraic manipulation over here. So we can add these two, all right, by taking a common denominator of sine theta. So if we add these two by taking a common denominator of sine theta, now basically what you're going to do here is times by sine theta, because we are taking a common denominator of sine theta. All right, so if we take a common denominator of sine theta, that means that we are going to multiply this side, this left hand side expression, this 3 sine theta, with sine theta. All right, so that is going to be 3 sine square theta plus 2 minus 2 sine square theta. So yeah, so we can do a bit of simplification over here. So we are left with sine square theta, 3 sine square theta minus 2 sine square theta is just sine theta, plus 2 over sine theta. Now the second step is to split this up. All right, how we can you have to just split this up. All right, since we have a common denominator of sine theta, so basically you can just split them up. So this is going to be sine square theta over sine theta plus 2 over sine theta. All right, now sine square theta is just same as sine square theta, sine theta times by sine theta over sine theta plus 2 sine theta. Now over here sines theta and sine theta cancels out. Sorry, this is 2 over sine theta. So that means that we have sine theta plus 2 sine theta. And this is, and we have proved it. So LHS is equal to RHS, hence shown. All right, and put a little box to show the end of the proof. All right, so now in the part B, solve for between 0 and x and 2 pi cos 3x 3 tan x plus 2 tan x is equal to 4 sin x minus 5. So basically now over here we can replace this thingy by this. All right, because hence means that you have to use something from the last question, and we have to use this thing to replace this. All right, in order to solve this trig equation. All right, so part B says that, let me take another color. So we have sine theta plus 2 sine theta is equal to 4 sine x, 4 sine x minus 5. So basically now let me just change these thetas into x. All right, we need in terms of x. All right, so now over here, just again do a bit of manipulation. We can get rid of this denominator over here by times by sine theta, sine x on all sides, times by sine x. All right, times by sine x. All right, times by sine x. All right, so this is going to give us sine squared x. This gets cancelled out, plus 2 is equal to 4 sine squared x minus 5 sine x. Now over here we minus both sides by sine squared x, minus sine squared x, and minus 2 and minus 2. All right, so this and this cancels out. We have 3 sine squared x minus 5 sine x minus 2. So basically now here I'm just making into one equation. Since there's sine squared x, you should know that it's going to be sine squared x, and there's sine x on its own, I mean not on its own, to the power of 1. So you should know that it is going to be a quadratic. So I've just made that into quadratic form. Now over here you need to solve the trigonometric equation. So so let me go to my calculator and just solve it. You can use quadratic formula as well. I will use my factorization. So if I factorize this, what you can do, if this is quadratic, what we can do over here to make things a bit easy, what you can do is let sine x is equal to y. Okay, so basically this is hidden quadratic, so you can just do 3y squared minus 5y minus 2, and if you factorize this you have y minus 2, and we have 3y plus 1. So y is equal to 2, y is equal to 2, and y is equal to minus 1 over 3. Right, now over here what I'm going to do now is let sine x is equal to 2, and let sine x is equal to minus 1 over 3. Now if you take sine inverse of 2 you get error. All right, and you cannot just write math error. All right, now you should know the reason why you get error. So let's say we have a sine graph. All right, and I'm just drawing a rough sketch of sine graphs, so like that. Now it is, you see the y coordinate, okay, the y coordinate, you see it is between minus 1 and 1, and we need for 2. So if you draw the straight line at 2 you have no solution, so you write no solutions in the range minus 1, y and 1, right? Now let's just solve this sine x minus 1 over 3, which lies somewhere over here, right? So now first thing is to do is just take sine inverse of it. Now you make sure that you check that it is in degrees or radians. It is in radians, so make sure you change your calculator in radian mode. All right, so you, otherwise you'll make a mistake. Now sine inverse of minus 1 over 3 is going to give us x is going to be minus 0.3398 something something something. All right, what you can do is you can draw a cast diagram. I'm going to draw an cast diagram. Okay, let me draw a bit smaller, I don't have enough space. So yeah, something like this. We have ASTC, cast diagram. Okay, this, now let's just label all the angles. So this is pi over 2. All right, this is going to be pi, this is going to be 3 over 2 pi, this is going to be 2 pi. All right, okay, so it is just as x. So now since the answer we got is negative, all right, since the answer we got is negative, we have to select the quadrants, sorry, you have to select the quadrants where sine is negative, and since the cast tells us where where these trigonometric ratios are positive. So first so I'm going to do here, I've labeled this AESTC. So basically what this means, that all trig ratios are positive, all sine ratios are positive, all tan ratios are positive, and all cos ratios are positive. Now we have to select which quadrants. Now since we are getting a negative answer, we have to select where sine is negative. Right, so that means that it is going to lie in this now in the third and the fourth quadrant. So now I'm going to draw a line here, right? And we can just label the sorry can label the 0.3398 lies here. 0.3398 lies somewhere here, right? Basically now over here, this thing is going to be plus pi plus theta, this angle, and this angle is going to be 2 pi minus theta, right? Now what I'm going to do is sine inverse of so basically now over here what you are going to do is add pi plus this 0.3398. You can store this value in your calculator, okay, or make sure that you just don't round off, all right? And we have 2 pi minus, now this is going to, theta is 0.3398, all right? Put this in calculator, let's see what he has. Okay, so we have two streams of answers. So now which we have to round it to how many decimal place? To three significant figures, all right? So three significant figures. So yeah, so this is going to be 3.48. Three significant, this is going to be 5.94, and that is our answer. Hope you understood some things. Quite a long one, quite a difficult one, but you just need to apply all your understanding over here and make sure that you have good practice on trigonometric identity. It is one of the hardest topic, but with practice it is just a piece of cake. All right, peace out.